Hi everyone. So in this video, we're going to work through a Year 12 Pure Maths question. Now, this question is from the AS 2018 paper, and it's mostly on factor theorem. So we've got a function here, g of x, which is 4x cubed minus 12x squared minus 15x plus 50. Part A says use the factor theorem to show that x plus 2 is a factor of g of x. Now, remember with the factor theorem, if you need to show that a particular factor like this x plus 2 is a factor of a function, just set the factor equal to 0. So x plus 2 equal to 0, and then take away the 2, x equals minus 2. So basically what we need to show in this question is we need to show that g of minus 2 is equal to 0. So that's all we'll do with this question in order to use the factor theorem. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018, and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams, and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. So g of minus 2, so sub in minus 2 into the function. So make it very clear when you do this question in an exam paper to the examiner that you are subbing in minus 2. So you're doing like what I'm doing here, where I'm explicitly subbing in the minus 2 in place of x, minus 15 times minus 2, and then plus 50 there. So we've got minus 2 cubed, that's going to be minus 8 times by 4, that would be minus 32. Then you've got minus 2 squared, which would be 4. 4 times 12 is going to be minus 48, so we've got minus 48 there. Then we've got minus 15 times minus 2, that's going to be a plus 30, and then 50 at the end there. So minus 32, take away minus 48, that would give you minus 80, and then 30 plus 50 is 80. So minus 80 plus 80 is 0 as required. So therefore, clearly, x plus 2 is a factor of g of x. So that's how you would answer part A to this question. Brilliant. So now let's look at part B. So part B says, hence show that g of x can be written in the form g of x equals x plus 2 multiplied by ax plus b squared, where a and b are integers to be found. So what we can do with this part B, let's just write down the function. So g of x is equal to, and it was 4x cubed minus 12x squared minus 15x plus 50. So now we know that this function is equal to this factor we found before, this factor we determined that was a factor, x plus 2 from part A, and then multiplied by some quadratic factor. What I'm going to do, I'm going to call this quadratic factor ax squared plus bx plus c, because remember, a quadratic expression multiplied by a linear expression gives you a cubic, and obviously g of x is a cubic. So clearly what we can say is that this 4x cubed term must be equal to x multiplied by ax squared. Okay, so this combination there. So clearly a must be 4. That's obvious from the multiplication. Now, if we look at the constants, so the 2 multiplied by the c, that must be 50. So we can also say, clearly, this 50 must be equal to 2 multiplied by c, so therefore c must be 25. Now, with that last missing constant, capital B, we can either use the x squared coefficient or the x coefficient. It doesn't matter which one we choose. I'm going to use the x squared coefficient. So if you multiply the x by the bx there, then that's going to give you an x squared term, so bx squared. So we can say also minus 12x squared must be equal to x multiplied by bx, and then also 2 multiplied by ax, but we know that a is 4. So 2 times 4x squared, that's going to be 8x squared, so plus 8x squared. We can remove the 8x squared to the left side, so this gives us a minus 20x squared there, and this is equal to bx squared. So hopefully it's obvious now, just cancelling out the x squareds there. B must be minus 20. So therefore our g of x must be x plus 2 multiplied by a, which was 4x squared, or 4 for a, and then b is minus 20, so minus 20x, and then c is 25. Now, if we just head back to the question very quickly, we want to show that g of x is x plus 2. We've got that, and then ax plus b squared. So we just need to factorize this quadratic that we've just found, basically, to answer the question. So again, we can say this is x plus 2, and then multiplied by the factorization of this. Now, this would be 2x plus, or 2x minus 5, I should say, 2x minus 5. 2x minus 5 and 2x minus 5. The reason why I know that is because obviously 2x times 2x gives you the 4x squared there, and then a minus 5 times a minus 5 gives you the 25, but we need a minus 20x, so that's why we need the negative sign instead of a positive 5. We need negative 5. So then obviously this is x plus 2 multiplied by 2x minus 5 all squared, and that is our answer there for part B. Just another quick interjection. If you are currently doing Edexcel A-level maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now let's go to part C of the question. So the figure 2 shows a sketch of part of the curve with the equation y equals g of x. Now we know what our g of x is. Let's just write this on the side here. This is x plus 2 multiplied by 2x minus 5 squared. So we have a root at x equals minus 2, clearly. So that must be this root there. And then we have another root at x equals 5 over 2, and that is the repeated root there. Why is that a repeated root? Well, because the factor 2x minus 5 there is squared. So that leads to a repeated root, i.e. a root whereby the graph touches the x-axis. So we have our roots there. So now for part C, use your answer to part B and the sketch to deduce values of x for which, and then part I, g of x is less than or equal to 0. So where is the curve, or where are the y values on that curve less than or equal to 0? So clearly they're less than or equal to 0 down here on the curve. So basically when x is less than or equal to minus 2. Now, after x equals minus 2, I mean, the curve up here is all positive, 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 positive. And then we come to this point here where the function is 0 again. So be careful with this question because we want to find the x values where the function is less than or equal to 0. So we actually do have to include that point there. So we can write down a final answer for part C down here. So part C, part I. we need x to be less than or equal to -2, or we can have x equal to 5/2 with this one. Now, the question did not want us to write the answer in set notation, so we don't need to worry about that with this question. But another question like this may want you to write an answer in set notation, so just bear that in mind. If you do want me to write down the answer in set notation in the comments, I can do that if you need to. Then for the last part II, write down the values of x for which g of 2 of x is equal to 0. So this is a bit of a graph transformation. So remember, when you have 2x in the argument of the function rather than x, this is a stretch in the x direction. So remember that. So let's just say here part II. So y equals g of x to y equals g of 2 of x is a stretch by a factor of 1/2. So remember, it is the reciprocal of the coefficient of the argument. So a half in this case, a stretch by a factor of a half in the x direction. So basically, you're squishing in the graph by a half, basically. So if we go back to the graph here, if we squish in everything by a half, then the roots will be basically multiplied by half. So the new roots of the graph will be half of this value. So half of this is going to give you -1. And then half of this one times by half is going to give you 5/4. So the answer to part II will be x equals -1 and 5/4. Let's write that down there. So therefore x equals -1 or x equals 5/4. Perfect. So that's the end of that question there. If you do have any comments or queries, do feel free to drop a comment below, but hopefully everything there was all fine.